motorist drives along a straight road at a constant speed of 80 meters per second. Just as she passes a parked motorcycle police officer, the officer takes off after her at a constant acceleration. If the officer maintains his constant value of acceleration, what is the speed of the police officer when he reaches the motorist? So they give you one number, just one. That's not very much information. This might make you feel troubled and all that, but don't worry. We got, first thing you always do is you draw this out. So you got this car. And it's going 80 meters per second, and it's constant. Oh, okay. Yeah, I didn't draw a car. Then we got the popo going on, and it chases after you. And it starts at 0, v naught at 0, but then it has an acceleration. And we know that the car has 80 meters per second and it's constant, so that means its acceleration is 0, right? So that right there signals me, hey, acceleration is 0. The only equation I can use is d equals to vt, okay? You can't really use another equation besides that. I mean, sure, you can manipulate this into v equals to d over t or whatever, you know, but it's the same equation. Anyways, moving on. Alright, so when I have these things, I have not very much information, I have two things going on, don't really know where to start. I always start by doing this. I always start by labeling what I got going on. I got the car, and I got the popo. Alright, the car has a V of 80 meters per second. Then we have distance, we don't know. Time, we don't know. The police has 0 meters per second. Then it has velocity, we don't know. Distance, we don't know. Time, we don't know. But acceleration, oh no, acceleration is what we're trying to find. Right? No. No, we don't know that either. Okay. But, these two things are the same for each. Why? Because we're forgetting about how long this car has been traveling 80 meters per second. We don't care about that. We're going to start right here where the police sees them and starts chasing after them. That's where we're going to start. So we have two of the same thing. And then time, of course, it's going to be the same time that they catch up together. It's going to be the same. So, all right, we got these variables set up, and we got an idea of what's going on. We got a whole lot missing from here. We got a whole lot missing from here, but at least we have a value, and there's only 3 variables. So let's start with the car. The car, we got d is equal to 80 times t. All right? That's all I can do right now. But then, we start with popo. We got d is equal to 0 t plus 1/2 a t squared. Why did I choose that? Why I chose that is because I really don't care right now about how fast the speed is that the police is going at the end of it. I know that's what I'm looking for eventually, but I got to start somewhere, right? Got to start somewhere. Quick switch of modes. Do you guys have? I know a lot of you that I've seen before in my office hours. You have that chart of kinematic equations with what variable is missing and all the 5 kinematic equations that you always use for constant acceleration. Do all of you have that chart? The 5 kinematic equations. I'm going to put it up anyways. It takes 2 seconds. All right. Alright, so how you use this is basically just a quick recap, just a quick summary. You look to see what you have. Say we have all three of these and we're looking for time, then we don't care about acceleration. We go to this chart, we say, okay, don't care about acceleration. A, acceleration. This equation does not have acceleration in it, so therefore you can use these three to then find t. That's how you use this. Okay? That's all you're ever going to need for kinematics and constant acceleration. All you need. These equations even turn into this, if you notice, that like d is equal to bt minus 1/2 at squared with a as 0 turns into d equals bt. Anyways, going back to this. All right, so we're gonna mess with this a little bit. And see how this d, we already know that it's the same as this d. So let's plug this 80t into that. All right. Oh, and this 0 cancels out that part. 0t, that goes away. So we're gonna change this to 80t is equal to 1/2 at squared. All right, cool. Now we have t on both sides, and so we only have two variables. Okay. So let's divide by t. Let's divide this by t. Now we have 80 is equal to 1/2 at. Right? That looks pretty simple. It looks like maybe I can go somewhere with that. So let's look for another equation now. We got 5 to choose from. We used one of them. We used the v naught t plus 1/2 at squared. Now we're gonna exempt v naught instead. So we're gonna use this equation. d is equal to vt minus 1/2 at squared. Now I'm picking these equations at random. Like I didn't pick these equations for some magical reason. You can pick any 4 of these equations and apply these mathematical substitutions, and you'll still end up with the same answer. You just have to make sure your algebra is right. So, anyways, I'm going to do d is equal to vt minus 1/2 at squared. And again, I'm just going to go ahead and plug in 80t for the d, because I know I'm going to do the same thing again. All right? d is equal to okay. Then we have 80t is equal to at squared. Cancel this out, cancel this out, cancel that guy out. Just divide the whole thing by one of the t's. Right? I'm going to shift over here even though it's still under the popo so everybody can see. Alright, now we have 80 is equal to v minus 1/2. This is what I did. Okay. Now before I continue this isn't done. 80 is equal to v minus 1/2 at, right? So we already got from this that 80 is equal to 1/2 at. You see this? So I'm going to plug in this 80 into here real quick. Do you see how that works? All right? Any questions? Cool. So now I got 80 equals to v minus 80. Bring it over. 160 is equal to v. And so that's the ending velocity for the police, and that turns out is the answer. Yes?
I'm sorry, when you say plug in that 80, you were talking about when 80 equals half the acceleration by time?
Yes. 80 is equal to 1/2 at. Okay? Now, over here, we have making it a little bit more clear, we took out all minus 1/2 AT, right? So we have this 1/2 AT that we know is equal to 80. So now it turns into 80 equals to V minus 80. Bring it over, 160, right? Boom. That can work. No problem, no problem. Alright, so like I said, for these kinds of problems, I didn't know to pick these two equations. There wasn't any reason besides those were the two equations I picked first for some reason. And they will apply, and with enough algebraic manipulation, you'll get it. It's just, I memorized that chart, and I memorized that chart by the time I hit the first test. It's not that I'm forcing you to, because you're going to have it, but maybe you might want to know how to make it into the easy access form that I have it up here, because they might, on your formula sheet, you know? I don't know. Whatever. It's just what I did.